I've just given an example here, right? So the basic requirement is you should know the two previous sketches which have shown that a force is acting towards the body of with the four quadrants. How do you write a force, an inclined force? How to write an horizontal component and vertical component? Very, very, very important. If you are not thorough in that, obviously you will get confused in the problem to solve. Is that right? Then it comes for next one. It goes to the force is acting away from the body, right? That is second point. So those two sketches, if you keep in mind, I would understand, and always keep it. You just write it in a paper or in the left hand side page of the notebook or the any other place. So see, keep it in hand so that you solve these questions easily, or you remember it. It's fine. Now this problem says three coplanar concurrent forces are acting at a point as shown in figure. Determine the resultant in magnitude and direction. Basically understand what is meant by magnitude, the value. What is magnitude? Magnitude means a weight, a value you can say, in terms of Newton. I will say, suppose 1 Newton or 10 Newton, whatever it is. Magnitude means a value. What do you mean by direction? At what angle the force is acting. Anything will have some zero angle. You have 0, 90, 180, 270, whatever it is. You should specify at what angle it goes. I am throwing a chalk piece like this. At what direction it goes? From the base horizontal, I will have some angle. That is the meaning. That's called direction. And the magnitude is the forces. How much is the force? 10 Newton. That is magnitude. So that is true. It is easy to understand. Now this figure shows there are three coplanar concurrent forces are given, right? And this is very simple. What is coplanar? A single plane. I have told you already. Concurrent means from the point it goes outside. That's it. Now acting at a point as shown in figure. Now how is this given? First force I can take from the first quadrant and come back. Okay. First quadrant, a magnitude value of 200 Newton, and the direction is theta is given as 45 degree. Second one, a second force of 400 Newton with an angle of 30 degree. The nature is like this. It's going like this. So this is your point. From the point it's acting outwards. The third one, a 600 Newton force with an angle of 60 degree. Is it clear? These three forces. I'll write what is the first step here? The inclined forces which is given should be converted into one horizontal force and vertical force. That's our basic first step. First step to solve. Now, first step I will write, resolve the forces. Resolve the force into components. Is it okay? So what I am doing, this is your first step. I will take first force. I will keep this 200 Newton as first force. I will write 200 Newton. It is the magnitude value. What is the angle given? 45 degree. Theta is 45 degree. This force is F. Or you can take F1. You take F1, F2 and F3. Better for understanding. F1 and theta is this. How to write this now? How will I resolve it? You have to draw a separate sketch. Only for this inclined force, you draw a separate sketch. Show the horizontal and vertical component. Immediately write the value for that. We have written, can you remember? Previous sketch. F h cos theta, F sin theta. If it is positive, positive value. Negative, negative value. The positive and negative, you know that. If it is up, it's positive. Right hand side positive. Down negative, left hand side negative. Very simple. First, you have to know the nature of this given force in the problem. How will I draw? I will draw like this. This is the nature. What is the angle given? Theta is equal to 45 degree. What is my first step? I will just draw another sketch to make it easier. I will draw like this. I should draw two components, one horizontal and vertical, to see that the arrow mark of those components come and meet the given problem. I will draw an horizontal. Clear? I will draw a vertical. This is my first step. Remember the same procedure we followed in the previous sketch. That's why I have said it's very, very important basics. You make a round. See, this round I am making it to specify the arrow mark. After writing, you should see that it goes and meets in the point. No, it's a common idea. How to write this? Basically write f is vertical sine theta. Theta value you can apply. The given in the question you can apply. Then this is one f cos theta. Now what to write? F is what value given? 200 Newton. What is theta given? 45. Just write it. F cos theta is, I'll let it bit better for you because it may not be consistent. Theta is f value, right? So f cos theta, what is f value here? 200 cos theta is 45. Is it positive or negative? Going towards right hand side. Positive. If it's negative, you write negative. Then f sin theta is what? F is what? 200 Newton. Again 200 it is. It is f1 or f. You can take f1, no problem. Theta is 45 degree. Sin 45 degree. This is the first step. You are resolving the force into components. This is clear? This is what you have to do. Like this, kindly do it for all three forces. It's only given in the problem three forces in three different quadrants, whatever it is. You may have even the three forces in single quadrant also. You need not bother about it. Your work is to first resolve the forces into components like this. So my first force is over. This 200 Newton. Is it clear? Now I will be making the second and third force. Very small, I'll just make it because. Okay. The second is what? The second quadrant is 400 Newton with 30 degree. What is the fashion? The body is like this, coming up. What is the value? It is 400 Newton. So before this, the value, first you have to write the arrow mark nature. Is it okay? I hope it is right. You draw a circle so to see that, you confirm that these arrow marks are coming towards this, so meet at a point. That's how we have to do it. Again f cos theta, but it's going towards left. Kindly remember, you will have to make it minus since it's going towards left hand side. And this is f sin theta. It's going up, so leave it as positive. Now write the value. What is f value given? It's 400 Newton. So it's keep the minus as it is because its nature it's going to minus 400 cos 45 degree. Is it okay? Then here f sin theta, what to write? F is what? 400. It's only positive because upward side. 400 sin. I'm sorry. It's 30 degree. I made a mistake. Just see the first sketch. Given the question 30 degree. 30 degree. Here also sin 30 degree. Very, very important to see that if you make a single mistake, either in writing this angle or writing this sine or cosine function, or if you make a mistake of assigning the sign convention, positive or negative, total problem will be the trouble. You will fail to get the answer. That's true, because one single sign convention, either positive or negative, will totally give a wrong answer. It's very, very important. Now here, now my force number 1 of 200 Newton with 45 degree is over. I have resolved it. Force number 2 with 400 Newton with 30 degree is over. And force number 3, what is that? 600. There is no force in the third quadrant, I left it. Fourth quadrant, 600 Newton. Again, how to write? The nature of the force. I'll write like this. Clear? I should write it a little bit better. Okay. I'll write one horizontal. I'll write vertical. Again, I put an arrow mark. A circle. This for understanding. I write simply f cos theta, f sin theta. Is it positive or negative? This should be f cos theta positive because right hand side. This f sin theta is coming down, negative. So this practice, if you properly write it or practice it, for 1 or 2 or maximum 3 problems in the starting period of unit number 1, which you will never commit a mistake until unit number 5. Please keep it in mind. This practice is very, very important. If you follow that and you get a concept very easily, quick to write it and get the answer, it will carry you till unit number 5. No doubt in that. Right? So, minus f sin theta because coming down, and f cos theta going towards right first. Now, what is the value of f here? I am talking about the force number 3. So, 600. F is 600 cos, what is the angle given? 60. I again tell you, don't bother about the angle which is vertical or horizontal. Here, the angles are given with respect to horizontal line, for this force with respect to horizontal line, for this force with respect to horizontal line, for this also with respect to horizontal line. If suppose, if this 45 degree is given with respect to vertical, what do you have to do? You know this totally is included 90 degree. 90 minus 45 is another 45. What about this one here? Suppose the 60 is in the opposite side. Here, what will you do? Total is 90. 90 minus 60 is 30. So we'll take it as 30. You have to consider only the horizontal side. Though it is sine, what angle I am writing? This angle with respect to horizontal I am writing. That is very, very important in mechanics. See, you can even take it as an opposite direction and write it for vertical. That will confuse you a lot. So kindly follow this method so that you need not bother about remaining vertical sides. If it is given with respect to vertical, total angle is 90, reduce that value, write for horizontal and leave this vertical. Finished. Then you keep on writing the angle. Only thing is you have to change sign for vertical, cos for horizontal. And towards right positive, up positive, down negative, left negative. Finished. Now 600 cos 60. That's it. Is it positive or negative? It's positive because toward right hand side. Here minus again. What is the f value? Again 600. What is sine? What is theta? Same 60 degree. I am writing negative because that's it. This is your, I can say it's the end of the problem. Very simple. If this you do it properly, remaining is only calculation. Calculation purpose you have to use your calculator to see that what is sine cos 30 degree, that you have to see. You press it, it comes some value. Multiply by 400, like that value. Okay? Then if it is negative value, positive value, add it up. Now I will come for the next step. So the resolving work is over. I will come for second step. First step is over, resolving. Second step. As we know, the resultant is nothing but sigma h plus sigma v. Root of sigma h square plus sigma v square is the resultant answer. That's your theory, right? Resultant of any body will have a summation of sigma horizontal component square and vertical component square. Now what I am doing, I will take only the sigma h. What the question says, determine the resultant and magnitude and direction. Okay? Resultant in magnitude and direction. That means the resultant R is a value of magnitude, say 100 or 10 Newton or 1 Newton in terms of Newton, and direction, what is the theta? Because even the resultant force will have some direction to go. Either it should be 0 degree, horizontal, or 90 degree, or some other degree. That's what we are finding out. Now to find out the resultant, what to do now? Sigma h, I am adding up, summing up all the horizontal components. Force number 1, force number 2, force number 3. How to sum it up now? Where is the horizontal component of force number 1? This is the horizontal component. 200 cos 45. You don't bother about vertical component because we are talking about horizontal component here. So I will write 200 cos 45. Is it negative or positive? It's positive. If you want to write positive, or you would leave it. Then coming to force number 2, we are worried only about the horizontal component, not the vertical one. Here what is the horizontal component here? It is minus 400 cos 30 in force number 2. Force number 2, force number 3. Okay? So this is what is it? Minus 400 cos 30 degree. It's clear? You can see the right hand side corner. Here it is given. The horizontal component is minus for force number 2. Force number 3 horizontal component, where is it? Here. Don't bother about vertical, only horizontal. It's again 600 cos 60 positive. Yes. It's plus 600 cos 60. Why it's plus? Going towards right degree. That's it. You use your calculator, get some value. No, I'm not doing it in the board. Say suppose it's 50 Newton. Positive or negative, I don't know, it may be 50 Newton. That answers you'll get it. Now, sigma V. This for what? Only vertical component. Positive means right, negative is right and negative. Where is the vertical component here? F sin theta, 200 sin 45. For the first force, vertical component. It's positive because up. Then, second force, vertical component, 400 sin 30. It's positive, 400 sin 30. Again here, third force, 600 sin 60 but negative because coming down. Minus 600 sin 60 degree. You get an answer for this. And your sigma h and sigma v is over. What do you have to do? Figure the resultant value r, the root of sigma h square plus sigma v square, you get a resultant value in terms of some Newton. You may get a value of positive or negative. I will not say that it is what is the value. You will resultant will be a negative answer, I don't know. Okay, you will get it transferred. After this step is over, this is your resultant answer. Say suppose I will write 100 Newton is the answer, suppose, and it may be a negative positive value, right? Suppose you get a value of negative. See, this value is dependent on what? It's a combination of your horizontal and vertical force. The result isn't any force like this or towards down, but this is a combination of your horizontal and vertical only, no? So this, it is either positive or negative, it's coming down. Based on that only you will get resultant. Now resultant is over. Then you have to find out what is asked here. Resultant in magnitude and direction. Direction means this resultant force of say 100 Newton, maybe it's positive or negative, I don't know, that we have to solve it. Okay, 100 Newton will have a direction, that means a theta from again horizontal. What is that value? To find out what? The formula is given, tan alpha is equal to sigma v by sigma h. This is your formula to find out the angle of the resultant force. Theta is for angle of every force in the body. Previous sketch. Okay, you can see the notes. And this tan alpha is an angle to find out the angle of the resultant force. Now what is alpha here? Tan inverse of sigma v by sigma h. Your sigma v value is given from here, sigma h is from here, substitute, get a value. Say suppose some degree, some 60 degree or 40 degree, whatever it is. After finding this, your problem is not over. What to do? Okay, I'll just erase out one area so that easy to write. After finding this, you have to draw a final graph, a small graph, specifying your sigma h value, sigma v value, resultant as well as the angle. Because when you take a plus, your sigma h will be a positive value, you write positive direction. If it is negative value, draw in negative direction. Sigma v will be positive, you write towards up, negative towards down. It's nature. In this problem, when you solve it, you will know that I am not knowing the answer, but still I will just write. Final answer will be like this. The sigma h value is positive and sigma v becomes negative. I am telling about when you solve it, your calculator will get the value of like this. You check it out. Okay. And obviously when your sigma v is down and sigma h is horizontal to our right hand side, where will become your resultant? See, resultant is a force with any direction. Suppose the resultant is right, like this. You will have to draw the arrow mark only like this. Any other answer for this? If an arrow mark is facing towards down, you will have these two answers. Now what I have shown here, I have shown this. I mean to say, your horizontal values come, sigma h, summation of horizontal forces become positive, and summation of vertical has become negative. So obviously these two arrow marks is confirmed. There is no change in that. So when these two components are like this, your resultant will have to be only this direction. You cannot write a resultant in opposite direction arrow mark because it's wrong. Because what is our policy? Procedure is like this. Which means horizontal should be left hand side, which means all the answers should be negative. And to the opposite is positive. By the answer in this question, you will get an positive horizontal force sigma h and negative sigma v. This is the answer. That you check it by your calculations. So obviously the resultant will be like this. Is this clear? Now I will draw resultant like this and just draw an arrow mark. Simply. This is your sketch. This you have to specify. And you have to show the alpha angle here. What is the angle? You will get an answer from this. I told you. This is the angle formed or angle from the horizontal line to the resultant force. This you have to indicate. So this will become your final answer. First step is to resolve it. Second step is to come to resultant sigma h and sigma v. Find out the answer, whatever the value. Then go for tan alpha, sigma v by sigma h. And alpha you find out, get some angle. I have just written an example of 60 degree, whatever it is. So indicate that in the final sketch. Only then the problem is 100% complete. If you leave this part, you will get only half of the marks. Because you have to specify the resultant value, magnitude and its direction where it goes towards. It may be in any quadrant. You cannot have a force other than 4 quadrants as per our mathematics. It is 1, 2, 4, 3 and 4. So I can say this resultant force is at the quadrant number 4 with an angle of some alpha. That's it. Okay. Now I have just given another 2 examples of 2 problems, right? This is problem number 2. So basically what is required? If any force is given, we have to resolve it into horizontal and vertical components, then go for its resultant values by summation of adding all the horizontal forces, vertical forces, then finally come to the angle, that is direction, that is magnitude and direction. So this is problem number 2. Just you can look at here. This question, what is given? Force number 1, 2, 3, 4. 4 forces are given. The same like previous, but thing is the angle will be different here. I will say this is some 30 degrees. This will be some 40 degree. Whatever the degree it is. No, I am not writing exactly in the center or side. I am just indicating the values. Now what did you do here? Force number 1 at angle of 40 degree. Force number 2 at angle of. Force number 1 is at angle of 40 degree, 30 degree with respect to horizontal. So this you can simply make it, draw it like this. Draw an horizontal force, a vertical force, write it 104 Newton, 104 Newton, this sine, vertical sine, 30 degree, and this is 104 cos 30. So this is the equation for everything you have to write. Why I have written this problem is, the difference in the second 4 is, it shows an angle with respect to 40 degree with respect to the vertical line. Now what will you do here? Same fashion. Okay. You write it. This force. I'm talking about this force. Okay. And you will have to write 156 is the value given, Newton. So you need one horizontal force, one vertical force. What is the angle given here? 40 degree with respect to vertical. What is the total angle here? You write 90 minus 40 to 50 degrees. You require this horizontal angle only, theta, 50 degree, to solve your question. So what will happen here? 156 cos is minus cos, what is this? 50 degree. And this is 156 sine, up it is positive 50 degree. And remaining things are same. I have just given this example to show that If the angle is with respect to vertical, what you have to do? The equation is same, I mean the idea is same. You have to reduce from the total angle, the angle pertaining to the vertical one, take the positive, I mean horizontal, forget about the vertical angle given. You have to resolve the components in terms of only the angle which is about to the horizontal line. That's it. That's very, very important. Now when you come for force number 1, 2, 3, third force, it's simple, 3 degree is given. Well, it's not 30 degree, 3 degree horizontal. So you'll write it. When you come for force number 4, what's happened here? They've given an angle of 9 degrees with respect to vertical one. How will I write again? I'll just draw this force, just like this. They're given a 9 degree here. And 9 degree is given. How to write? Basically it is 228. It's 228 Newton. Value given. So it's 228. I should make it like it, horizontal and vertical. 228 will be cos negative this side, 9 degree. Is it 9 degree? No. Because the vertical angle is 9 degree. You have to reduce from this 90. How do you reduce? Already you have a 3 degree here. Total makes 90. 90 minus this 3 minus this 9. Any force given, you will have to reduce that value. 90 minus this 3 minus 9. So it will become 90 minus 3 degree, this one, minus 9. I can say 90 minus 12 degree. That is how much? 78? 78 degrees is the angle. So 228 cos 78 degree. It is negative because coming towards left hand. I am talking about this force. Again this one, 228 sin 78 degree. I am talking about only the value for this. How much is this? Again negative. When you go for this one, same thing. You just take 90 minus 3 degrees. Okay? This is it. Why I am not reducing 90 minus 3 minus 9 for this force? Why should I reduce only for this force? The reason of reducing, adding up this is, you start from 0 degree, you go to 180 degree, then come to 270 degrees. The basic idea is the force is acting from first angle, then second, third and fourth. So when I come to this, only the horizontal is considered, the remaining can be kept as it is. When I come to this one, you have traveled from the 0 and come here. Or you can directly make it directly 180 minus this angle also. So instead of that, you can take a value of 90 minus 9 minus 3. Becomes 90 minus 12, 78 degrees. That's the idea. Then further solve it. Add up all the horizontal forces, vertical forces, go for resultant, go for alpha, get the values and write the final sketch of a graph. Don't forget. So that's about your sketch number 2. Clear? And now there's one more question given. You know, that you can solve it. This question number 2, you can solve it, find out the answer. The calculation part is left out for you. Your question number 3, there's one question given. For this, there's no sketch specified, that you will have to develop a sketch or write a sketch. The forces 10 Newton, 20 Newton, 30 Newton, 40 Newton are acting on one of the vertices. What will be vertices? Vertex. Vertices. I hope that you remember the drawing what you did in last semester, first semester of your engineering course. Yeah? Vertex or vertices. You take any polygon, take a triangle. What is the vertex here? This point is called your vertices or vertex. And this one line I can say it's a vertices. Can you understand? And this will become another vertices. So this point is vertex point. So 10 Newton, 20 Newton, 30 and 40 Newton are acting on one of the vertices of a regular pentagon. Pentagon contains sides of 5. I'll write a pentagon here. This is pentagon. Why it is written regular pentagon? This is called regular pentagon. You can even write pentagon like this. Is that right? This will not become a regular pentagon. A regular pentagon is one which has its base resting on the ground. This is again your drawing concept that we've already learnt and clear the paper also, right? So that's it. So you will have how many vertices here? 1, 2, 3, 4. How many forces given? 10, 20, 30, 40. So understanding the problem is very important. Once you write it, again this work. It will be easy. So 10, 20, 30, 40 are acting on one of the vertices, that means each and every one of a regular pentagon, towards the other 4 vertices taken in order. You start with one point, go for other 4. That means you cannot start here. You should show this 10 Newton, the 20, 30 and 40 also. How will you show? I'll just start from here. I'll show this 10 Newton here. Is it clear? How can you take the 20 Newton? Can I start from here and go? No. Because the starting point of the force is always a single point. It has got different components. One is here, second one goes here. That is why it's given vertices of a regular pentagon towards the other 4 side vertices, acting on one only, but it's towards the other 4 vertices. That means it starts from here itself, but it goes on but 2. How much is this Newton? 20 Newton. How much is this one? 30. How much is that? 40. So this is how your problem is. So this is the actual sketch given. The angle you have to find out. How do you find out an angle? How do you draw a pentagon? Pentagon of 5 sides. Very simple. 360 by 5. How much is this? 70 degree? 72 degrees? 72 degrees, 72 into 5 becomes 360. Okay? So this is your angle. This is an angle for, how do you draw this angle? Every force, this pentagon will have this included angle. This angle is 72 degrees. If you take this one, it will become 108 degree, the remaining one. So, in this question, you need an angle for every force. 1, 2, 3. That too from where? From the base only you are choosing it. Suppose you take this force from here. For this force, I'll just show it in the other way, better understanding. So first one is this, second I can say this one, and third it comes this. All these angle how? For this force it is 0 degree because flat. This force some other angle I want, theta 1. I can say theta 1 for force number 2. This is 1. Force number 1 is 0 degree. Force number 2 is theta 2. I'll write some angle I wanted. Force number 3 is this 3. I need theta 3. Force number 4 is theta 4. How do I find out? See, for an included angle, you have a formula called 2n minus 4 into 90 degree. Sorry, 2n minus, 4 into 90 degree. This n shows the number of sides. Number of sides of a pentagon. This is a 5 here. Number of sides is 5 because pentagon is 5 sides. So 2 into 5 is your 10 minus 4 is how much? 6 into 90. 90 is 6 into 90, 54. That is 540. The 540 should be your total angle for drawing this total sketch. How do you make it 540? You divide by this each and every angle divided by 5. The remaining you will give each and every angle subtended here. Okay, that calculation you can make it. Remember the formula, it's obviously available in the book also. The purpose of telling this problem is, the forces is given like this. You will have to think properly by understanding these technical words and write it, arrange the forces properly. By chance if you think, I start from here, go for 10 Newton, 20 if you travel from here, 30 from here and 40 from here, whole get flopped. It's wrong. You will have to travel from one point only, and it says starting from one point goes on different vertices. It's clear? Then you can solve and get the answer.